Assalamualaikum and hi everyone. We are from Group 1 and today we will be presenting about ceramics, specifically on the processing and application of ceramics. So what is casting? Casting is a process where molten material such as glass or ceramic slurry is poured into a mold to obtain desired shape. From the diagram, we can see the different types of molds. The molten material is poured into mold cavity and after cooling, it solidifies into the shape. In some cases, the mold rotates. This helps distribute the material evenly, especially for a hollow shape. For example, this is similar to pouring chocolate into a mold to make different shape. Next, in rolling process, molten glass is passed through rollers to form a flat sheet. The thickness of a glass depends on gap between rollers. However, the surface produced is not very smooth, so additional polishing is required. This method is commonly used for pattern or texture glass. It is similar to rolling dough using a rolling pan. In plate glass drawing, the glass is heated at high temperature until it becomes liquid. Then, the molten glass is continuously pulled out using rollers. After that, the pulling action shapes the glass into flat sheet with controlled thickness. The glass is then cooled to prevent cracking. Finally, it forms solid plate glass. This process is used to produce plate glass sheet for applications such as window and glass panels. Next, the float process is most important modern method for producing plate glass. In this process, molten glass floats on molten tire because of gravity and surface tension. The glass spreads out and becomes very smooth and flat. After that, the glass moves through heating and cooling zone to slowly solidify. This method produces high quality glass with uniform thickness and very smooth surface. It is widely used for windows, mirrors, and screen. For example, like Apple Store at TRX. Okay, next, annealing is a part of the float glass process. It is a controlled process used to remove internal stress in glass. Annealing is a crucial step in float glass process to ensure final product has good mechanical strength and free from internal stress. Glass that is not annealed can easily crack or break when exposed to small temperature changes or impacts. If glass is not annealed, thermal stress from quenching remain inside the glass and reduce its overall strength. So, let's look at the differences of rolling process and float process. In the rolling process, molten glass is passed through rollers to form flat sheet. The thickness of glass controlled by gap between roller. However, surface produced is usually rough and may require polishing. This process is simpler and cheaper and commonly used for pattern or decorative glass. In floating, molten glass floats on molten tin and spread naturally to form flat and uniform shape. This method produces glass with smooth surface without polishing. It is widely used for high-quality applications such as window, mirror, and modern building glass.
First, chemicals are added in glass to improve its properties. For example, some chemicals help the glass melt faster, which saves energy during production. Others act as stabilizer to make the glass stronger and more durable. In addition, certain elements like rare earth metals improve optical properties, making the glass clearer, and some chemicals are also used to remove bubbles, while others give colors such as a green, blue, or yellow. Next, ceramics are widely used as abrasive because they are very hard material. They are used for grading, cutting, polishing, and cleaning surface through friction. For example, it includes silicon carbide and diamond. Ceramics are also important in construction. They are used in roads, bridges, buildings, and dams because they are strong, durable, and resistant to weather conditions. Besides that, ceramics are good electrical insulator and can withstand high temperature. This makes them suitable for use heating elements, cables, furnaces, and reactors. Modern or advanced ceramics such as silicon carbide and zirconia are used in engine and high temperature environment. This material can be strengthened by editing fibers, making them less brittle and more resistant wear. Ceramics have many applications including structural uses like cutting tools, electrical components like capacitor, protective coating, and also in environmental uses such as filters and catalysts. Ceramics are important materials due to their hardness, heat resistance, and durability, although they can be brittle, which can be improved with modern technique.
starter is one of the forced induction device that increases an engine's power and efficiency by using exhaust gases to drive a turbine, which is spin a compressor to force more air into a cylinder. So, if we look at the red circle, so hot exhaust gas from the engine flows through this component. So this part is exposed to a very high temperature, and these ceramic are used here because they can withstand extremely high temperature without melting or degrading. They also have a good thermal stability and do not react easily with gases. For this slide, the application is ceramic brake disc used in high-performance vehicle. When a car brakes, friction between the brake pad and the brake disc produces a large amount of heat. Ceramic brake discs are preferred because they can withstand this very high temperature without deforming easily. Besides that, ceramic brake discs are lighter compared to conventional metal brake discs, this helps reduce the overall weight of vehicle, improving fuel efficiency and handling. Another advantage is their high wear resistance. They last longer and produce less brake dust. Therefore, ceramic brake discs provide better braking performance, improved thermal stability, and longer lifespan compared to conventional brake material. This slide explains the use of ceramic in engine components such as valve, seal, and bearings. Engine components operate under high temperature and high friction conditions. Because of this, material used must be strong and resistant to wear. Ceramic are suitable because they have high hardness, excellent heat resistance, and good wear resistance. They also have good thermal conductivity, which help dissipate heat quickly. Due to these properties, ceramic material can maintain their performance without deformation even under extreme conditions. Therefore, ceramic are commonly used in automotive engine parts that require durability and thermal stability. For this slide, I will explain ceramic armor system. Ceramic armor is designed to stop or resist high-speed projectiles such as bullets and fragments. Ceramic are used because they have very high hardness. When a projectile hits the ceramic surface, the ceramic helps absorb and disperse the impact energy. Another advantage is that ceramic materials have low density, meaning they are lightweight while still providing a strong protection. Because of this combination of high hardness and light-quick properties, ceramic are widely used in body armor and protective equipment. Ceramic armor. Ceramic armor systems are used to protect military personnel and equipment. For the advantage, it has a low density of the material, which is I have just said earlier, and that can lead to weight-efficient armor system. Typical ceramic materials are used in armor system include alumina, boron carbide, silicon carbide, and titanium diboride. So, the ceramic material is discontinuous and is sandwiched between a more ductile outer and inner skin. So, the outer skin must be hard enough to shatter the projectile. So, most of the impact energy is absorbed by the fracturing of the ceramic, and any remaining kinetic energy is absorbed by the inner skin that also serves to contain the fragment of the ceramic and the projectile, that preventing severe impact with the personnel or equipment being protected. And then, alumina ceramic or Kevlar composite system in sheet about 20 mm thick are used to protect key areas of Hercules aircraft, which is cockpit crew, instrument, and loadmaster station. So, this lightweight solution provided an efficient or removable or replaceable armor system. So, it's similar system used on armor personnel carriers. Okay, so for the last one is the structure of a ceramic composite armor system. So in this slide, it consists of three main layers, which is for the first one is outer hard skin, and then the second one is ceramic layer discontinuous, and then for the last one is inner ductile skin, which is for the first one. For the outer hard skins, when a projectile hit the armor, the outer hard layer first contact the projectile. So this hard surface helps to shatter or break the projectile into smaller fragments. So the second one is ceramic layer discontinuous. So the ceramic layer absorbs most of the impact energy. So the ceramic material fracture during impacts that help dissipate the energy and reduce the penetration. Finally, the inner ductile skin absorbs the remaining energy. It also traps the fragment from the projectile and broken ceramic that preventing them from reaching the personnel and equipment behind the armor. So that's it.